Hey, so today we are going to be working on some application problems of exponential functions. You hear application problems, you see word problems. There's just a couple of types here that we're going to go through. I think by the time we're done, you'll find them fairly easy, mostly easy. But before I start, I got to lay some groundwork, some stuff that you're supposed to have already learned, but it's one of those things you probably cover in 7th, 8th grade math, maybe something like that. I'm not really sure. But these are applications of a financial nature. So basically, loans or investments. So the world of earning interest very much relates to exponential functions. But what you learned way back, like I was hinting at, is something called simple interest. Well, all right, so let me start at the beginning. Interest is money that you earn on an investment or you pay on a loan. It's like extra. So if you borrow, $80,000 for an exotic car, you're not going to pay $80,000 for it. You're going to pay over $100,000 for it by the time it's all said and done because of the extra interest. So there's a type of interest called simple interest, and the formula is right here. I think it's called simple because all you have to do is multiply a few things together. Interest is equal to P times R times T. P stands for principal, which is the amount you borrow, or if you're making an investment, it's the amount you put into the investment. R is the interest rate, and this one is always going to be a percent. T is time, and it's usually in years. If it's not in years, there'll be some sort of specific statement about that, but generally it's in years. And then there's a second formula that goes with it. Amount equals principal plus interest. So I'm going to go through a very basic example of this. Again, kind of a throwback to an earlier time in school. Like I said, probably 8th grade math, maybe 7th grade, I'm not sure. But if you borrow $6,000 for 3 years on a 5% interest loan, how much interest will you pay, and what is the total amount that you'll pay? So for this problem, let me switch colors here. $6,000 is your principal amount. 3 years is the time. 5% is the rate. Basically, if you plug those three numbers into this formula, we will be able to answer the first question, how much interest? So let's do that. I want to do these notes in blue. So interest equals $6,000 multiplied by 5%. Now 5%, if you were to just put a 5 here, you will get the answer wrong. 5%, if you recall, is 5/100ths. So we need to move that decimal 2 places over, make it 0.05. And because we have a decimal point and that times, I'm going to use parentheses for times instead of the dot. So we change the 5% to 0.05. That's something you're just going to have to do and become accustomed to doing. So principal times rate times time, so we have to multiply this by 3. But simply type this into a calculator, or if you're wicked smart, do it in your head. And we come up with $900. That means there is an interest charge of $900 on that loan. That's the first question. How much interest will you pay? Then what is the total amount? Well, amount equals principal plus interest, so that's $6,000 plus $900 for $6,900. So this is a feasible situation for maybe a used car. This could be a real life thing. A $6,000 car, you only want a loan for 3 years. A bank's offering you a loan at 5% interest. Then at the end of those 3 years, for your $6,000 car, you'll end up paying a total of $6,900. That $900 is interest. That's basically profit for the bank. That's why they loan money. They want to get the interest charge so that they can show a profit for that. Okay, so that's fundamental, basic, or simple interest. What we're going to learn and what relates to exponential functions is called compound interest. So for the same loan above, how much would be paid in a loan that is compounded monthly? So there's a new formula here. It still has P for principal, R for rate, T for time, but it has a new variable, as you can see, N. And N stands for the number of times interest is compounded. So basically, banks learned that if you charge interest more often, you make more profit. So they structured these loans. So if I want to work this out in the same scenario above, a $6,000 loan, 1 plus R, remember R is 0.05, divided by N. So now we got to read the problem and see what N is. And the clue is in this word right here, monthly. So you know there are 12 months in a year. That means that rate, that interest, is going to be split over 12 months, but it's going to be charged 12 times. So it's to the 12th power. And then that number of times is spread out over 3 years. So it's N times T. So what they do is they divide the interest rate by 12, so it's a very small rate, but then they charge it more often. Now let's type this into the calculator and see what happens. 6,000 parenthesis 1 plus 0.05 over 12, and that is raised to the, oops, did not want to do that, raised to the 12 times 3 power, and this works out to be $6,968.83. So you see that the bank making this loan makes $68.83 more than the bank that did that other type of loan. But the deal is they can still advertise it as a 5% loan. So it seems to the consumer to be the same, but they make more profit. Now you might look at $68.83 and be like, yeah, so what? That's a couple, fill-ups in the gas tank. It's not a big deal. Well, okay, so imagine loans bigger than $6,000. Imagine thousands and thousands of loans being made all the time. That little bit of extra profit for the bank really adds up. So now let's say they had the same situation, but the loan is compounded daily. So we have the same formula, $6,000, 1 plus 0.05 over. Now, 12 months in a year, how many days are in a year? It's 365. Okay, counting leap years, it works out to be 365.25, but we're not going to worry about that. We'll just call it 365 days per year. So this is the same exact loan information, $6,000 loan, 5% interest, 3 years. This one's just compounded differently. 6,000 parenthesis 1 plus 0.05 divided by 365, and then that is raised to the 365 times 3 power. This works out to be, did it again, here we go, $6,970.93. Slightly more than the previous one, only a couple of dollars, but again, a couple of dollars in thousands and thousands of transactions really adds up to a lot of extra profit for the bank. Now the flip side is this could have been a $6,000 investment where there's a 5% interest guarantee and you're going to keep the money in the investment for 3 years. So that $900, instead of being a charge, that's money that you make. So that's how, people retire, is they accrue interest over the years. So earning $900 in 3 years of interest is pretty good. Earning $968.83 over the same amount of time is better. Earning $970.93 is even better yet. So, and then if you look at, most people don't invest for 3 years when they retire. That's maybe 30 years, and they don't just invest $6,000. They're constantly adding money in. You can see that compounding really does a lot better for earning interest and putting a person toward retirement than this simple interest loan that, again, you learn in 7th or 8th grade because the math is easy. So the compound interest formula is a very realistic formula that can be applied specifically in borrowing or investing money. There's other applications too we're just not going to get into right now because I don't think you want to watch an hour-long video. So let's look at some problems that you're going to be expected to know how to do. As usual, I'll do the evens, so 2, 4, 6, and 8, and then you will do the odds. Let me write the formula up at the top. Amount equals principal times 1 plus R over N to the nt power. All right. Daryl invests $896 in a retirement account with fixed interest rate of 7%, compounded 6 times per year. What will the account balance be in 13 years? All right, this is the principal. That's how much he's putting into the bank. 7% is the rate. 6 times per year is the n, the number of times it's compounded. 13 is the t, time. What will the account balance be? That means we're trying to find A, the total amount. So that's just telling us to use this formula. So here goes. A equals, let me zoom in a little. Oops. 2896 times 1 plus 0.07. Remember, you take that and move the decimal 2 places over. 0.07 over 6, that's this number, to the 6 times 13 power. Type this into the calculator and you will have your answer. 2896, 6, parenthesis 1 plus 0.07 over 6. And that is going to be raised to the 6 times 13 power. The amount of money in the bank after 13 years, $7,156.80. That's so much larger than the original $2,800. Let's check the answer. Make sure I didn't do anything goofy. 7,156.80. And there we go. So, 13 years, again, imagine 30 years, and imagine you're investing not just $2,896, but maybe every paycheck you keep adding to it. But anyway, this is a basic sort of example. Let's look at number 4. Daniel invests. Is that the same 2,978? Oh, it's close. That's weird. So this is the principal that's being invested into an account with a fixed rate. There's our R, compounded 2 times per year. That's our N for 17 years, which is time. So we work out this formula. A equals 2,978 times 1 plus 0.03 over 2. 2 is the N, raised to the 2 times 17 power. At this point, just data entry, 2978, parenthesis 1 plus 0.03 over 2, and then that's raised to the 2 times 17 power, $4,940.49. Now that doesn't seem like much after 17 years. Did I make some kind of a mistake? Nope, that's the right answer. Why would that be so much less? Well, 2 reasons. 3% is a lot less than 7%, like in this problem. And 2 times per year is a lot less frequently than 6 times per year. So yeah, that does actually make sense. That's the right answer. Now let's read number 6. Aaliyah invests $4,781. That's a principal amount in a savings account with a fixed annual rate of 7%. That's our time, or our rate. Compounded 12 times per year. That's our N. How long will it take for the account balance to reach $10,302.77? Okay, so now they're actually giving us the amount, and how long will it take is time. So when we set up this formula here, let me copy the formula down. P plus 1 times 1 plus R over N to the NT. So our amount is 10,302.77. Our principal, 4,781. 1 plus 0.07 over N to the N. Oops, that was kind of a mistake. The N we know is 12. The time is an unknown. Well, this is an exponential equation. The variable is in the exponent, and we need to solve this. So we're going to go through some steps to solve this. It's going to take a little bit of work. Fair warning. But there's only 2 of these for you, and I think you'll get it. So first thing I'm going to do is simplify what's in the parentheses. Let me change the highlighter color. This right here, this is a number. So let's find the actual value. 1 plus 0.07 divided by 12. Wow, 1. Now you might be tempted to round that off to just 1. That would give you disastrous results. You need to go 4 decimal places at least. We'll go 4 decimal places in order to do this. So that's our equation. I'm going to bring it down here so I have a little more room to work with it. Okay, so we need to solve this. This is a lot like yesterday's work. To solve for t, because this is times, I'm going to divide both sides by 4781. Divide by 4781. So $10,302.77. Oops, where's my decimal? Divided by 4,781. 2.1549. Again, we're going with, cross those out. We're going with 4 decimal places. Now to isolate t, I need to do something to cancel out this number so that I can get the variable by itself. How do you cancel out a base? Oh yeah, they're called logarithms. And this is the type of problem where I normally leave a space here. So to cancel that out, I need to take the log, whose base is 1.0058. That will cancel this out, but then I have to do the same thing to the other, lug? No. Do the same thing to the other side. So over here I have 12t, and over on the other side, this is where I want to use my calculator. So function, miscellaneous, the log a button. A is 1.0058, and then this number is 2.1549. We get 132.7532. Finally, to solve for t, you need to divide by 12, and you get t equals. Now, I need to divide this by 12. I can just go to the previous entry and hit divide by 12. And here I get, now if we're going to round off, 11. Why don't I round off to 4 decimal places? Well, we're trying to find how many years it's going to take. Now, if it was like 11.5 or something like that, it would make sense to say, 11 and a half years. But on this one, I think we're safe rounding off to the nearest whole number. It's going to take 11 years for Aaliyah to turn this much money into that much money. And that can be helpful to calculate how many years it takes to reach a certain amount of money. Maybe you're going to make a big purchase. Maybe, within the next 10 years, she wants to be able to buy a car for a certain amount of money, and she just calculates, well, it's going to take 11 years. So that's information that might tell her to save more money or wait longer. Although most people borrow money and then pay it back, so they pay interest instead of earning interest, but that's a whole other philosophical debate on how to manage your personal finances. So I won't get into that. Let's just say this was a financial problem. We used the compound interest formula, which is an exponential formula, which can be solved with logarithms. All right, we're going to do one. Well, no, I should check and make sure number 6 is really 11 years. There we go. Right there. Okay, do number 8 just to make sure that you've got it. So Deshaun invests this much money, that's our principal. Fixed rate of this much, that's our rate. And 2 times per year is how often it's compounded. And he wants to earn a total amount of that much. So we've got our A, P, R, and N. And again, we're trying to calculate how long. That means T is the unknown. So I'm going to plug this all into that formula. One plus R over N 0.02 over 2 to the NT 2T. So just review this real quickly. The principal goes here for P. The rate up here where the decimal moved 2 places. N is down here and up there. The total amount right there. So what do I need to do? I need to take the part that's in parentheses and make that into just a number, 1 plus 0.02 divided by 2. So 1 plus 0.02 divided by 2 is 1.01. Okay, maybe we could have done that without a calculator. Oops. Okay, so what we have here now is an exponential equation which we can solve. We can isolate that variable, and we're going to do it using a logarithm. Before I do that, I do need to cancel out this 2,741, which is multiplied. Opposite of multiply is divide, so I'm going to divide both sides by 2741. Cancel that out. The left, I definitely need a calculator. 3088.63 divided by 2741, 1.1268. Again, 4 decimal places on these steps. The final answer might be a little different than 4 decimal places, but in these steps, you definitely want to do that. And got a little careless again. I like to leave a space here. To isolate t, I need to be able to cancel out this base number. A logarithm cancels a base. So log 101, log base 1.01. The left cancels out, gives me 2t. The right-hand side I need a calculator for. So function, miscellaneous, the log a button. 1.01 is the base. 1.1268 is the argument. So we get 10.7304. Now divide both sides by 2. And then I can just go up here and type in divided by 2 and 5.4 years. Okay, is that? This says 6 years. Now, why would they answer like that? Let's think this through. Could I have made a mistake and got the wrong answer? So I need to see, did I plug in the numbers correctly? Everything appears to be in the right spot. Did we do this part right? Yeah, 2 divided by 2 is 1.01. Let me double check, make sure I didn't type anything in wrong. That looks right. Take the log of both sides. All right, all the calculations seem right. So why would they call 5.4 years t? Okay. Well, if we followed regular rules of rounding, we would call that 5, right? Because this number would cause us to round down. But if you are trying to say that you're going to earn a certain amount of money in 5 years, and it's clearly going to take more than 5 years, then the rules of rounding, although they apply in certain mathematical senses, doesn't really apply here. It's not going to take 5 years. It's going to take more than 5 years. 0.4, what's 0.4 years? Well, that's, a couple of months, so we could figure that as to 5 years and how many months exactly. But it looks like they just rounded up to the nearest year, called it 6 years, because 5 years isn't enough time. 6 years is enough time, and it's at least a whole number. So if you look at these answers, they're all rounded off to the nearest year, and I would expect that any rounding rounds up, even if it violates the rule of rounding. So even if this worked out to be 5.1, we would round it up to 6, because it would take more than 5 years. So it's like, if it takes 5.4 buckets of paint to paint a house, approximately how many buckets of paint are you going to buy? You wouldn't say 5, because you wouldn't be able to paint the whole house. You'd have to buy 6 buckets of paint, even though you have some left over. So I think it's one of those scenarios where the rounding is done a certain way because the context of the problem just sort of demands it to be done that way. Okay, so what does it come down to? There was some background knowledge that really you don't have to dwell on too much. It's good if you understand it. The new knowledge is this formula and how to use it. And we're looking at using it in 2 different ways. You plug the numbers in, type it into a calculator, bam, get an answer. Or you plug the numbers in, and there's a variable in the power which makes it an exponential equation, and then solving it involves logarithms. So there's our two very specific scenarios, the things that you're going to need to learn how to do. So try these 4 problems, text, comment, email if you have any questions, and hopefully it goes good for you. Get this work done and turn it in. See you later.